This video is brought to you by Greater Commons. Greater learning, greater opportunities, greater life. Visit us at greatercommons.com.
So we're going to create a 3-page website. We just did this, the students did this exercise in class. We're going to use Go to do it. And so I'm in folder 19 inside 46 spring 17 inside 00 temp. And if you're watching this online, you're like, but where? But where is that? github.com/goes to 11 is me. And you come here and you can find Golang Web Dev right there. And so this is it. We're in 00 temp, and then inside that is 46, and inside that's 19. Cool. So first thing is just type in main, and http.handle func is where you put it. Sorry, http listen and serve. Listen and serve is where you start out, and then put in the port you want to listen on, and nil for default serve mux. And if you don't know what default serve mux is, you could go onto my YouTube channel, YouTube Todd McLeod, and we have a series of videos there where we're learning about all this, and those videos are right here. So we talked about all this last week right here, so you can just look at those videos and then search my account for those videos. Alright, so right there I'm not getting the package import, but if I hold down on my computer on a Mac, option return, it'll give me choices, and I want the net HTTP, and it brings in the import. So that's really like the first place I start. And then http.handle func, and give it a pattern. And so anything coming in at route, at index, will be handled by func index. And so I come down here and then I create a func, and it has to be of a certain signature, and it's got to be a response writer. So servers listen for requests and write responses, and that's what this function is. And if you go look at the documentation on that, we've seen this before, godoc.org, and we want to go to net HTTP. I cleared out all my browsing history, so I don't have the complete links anymore. There's listen and serve right there. It takes that address, the port you want to listen on, and then it takes a handler. And if you use nil, right, you're using the default serve mux. And so it just passes a handler in there. And a handler is really the entry point to understanding the HTTP package. And so a handler is this right down here, type handler right there. Type handler is any type that has the method attached to it, serve HTTP, response writer, pointer to request, is also type handler. And again, we see this theme of a request and a response, because that's what servers do. Right? So this would be able to handle, incoming requests and write responses. So it's type handler. And so to listen and serve takes that address and a handler, and it returns an error. A lot of times people don't check that error because it's usually right at the end, and if it dies, then your web server stops running. And so that's what we use. And with default serve mux, is this a good reminder for you guys, or am I boring you because we talked about this last week? So with default serve mux, if we look at, when we're using default serve mux, we look at handle and handle func, it says it registers the handler for the given pattern with default serve mux, registers the handler function for the given pattern with default serve mux. So handle func takes a value of this type, right? A function with those parameters. And that's exactly what we gave it. Handle func wants a route, it wants a pattern, and then it wants a value of this type. Well, we're giving it index. What is index? It is a function with the response writer and a request as parameters. A response writer and a request as parameters, right? That's the type. Everything highlighted in blue is a type. Int's a type, string's a type, bool's a type. That's a type. And this value here, index, the identifier by which that function is known, index is of that type. It's a func with a request and response writer as its parameters, pointer to request. And so now here I could just do something like io.writeString, right? And writeString wants a writer, and then hello from index. Right, so write string, if you look at that, wants a writer, something of implementing the writer interface, and a string, and it returns int and error, and number of bytes written and an error if there is one. But a lot of times, for whatever reason, like that's not checked. If we were to write this clean, and it's really good to know about, because if there's ever any problems, you want to see what that error is, and it'll tell you that error. And so some of y'all had some problems this last week, and okay, well, let's check the error on listen and serve and see what's going on. Or let's check if we're using write string, let's check n colon error colon equals, n comma error colon equals. And so we could check that, and we could print that error out, format print line error. And then we could also format print line just FYI, right, number of bytes written. I'm pretty sure that's what the n is. N is return write int error. So write is what gets returned. N is returns number of bytes written. So there we go. So, when you teach it, if you throw that error checking in there, it looks like a lot more code. And it doesn't allow you to focus in on what's important. We'll run this just right here. We're done with just creating one route. We'll run this just so we could see that run. Hello from index. And since it should have written how many bytes were written. Bytes written 16, bytes written 16. It's interesting that it hit it twice. Right? Do you see that? It hit it twice. It asked for index twice, but I only went there once. Because in my code, right here, I'm doing bytes written just one time inside index. When something comes to index, then it runs that code, and bytes written got printed twice. What gives? Well, maybe it's something to do with Chrome. Let's try Firefox. So we got 2 bytes written up there, and we could even do this. Two there. Wrote 2 there. What about from I don't know what else do I have in here. Atom, Safari. Whoa, man. It's jumping the gun, baby. Right? Jumped out a lot. So part of what's going on there is some other stuff's being asked for. And you can see different browsers ask for different amounts. It seemed like Safari grabbed a whole bunch, right? We had 2 from Chrome, 2 from Firefox, and then Safari fired off 4 requests to index. It's kind of interesting. So part of one of the things they're asking for is the fav icon. And if I wanted to, I could clean that up with the fav icon not found handler. And so I could just come into our GitHub code, goes to 11 Golang Web Dev, and I could search this repository, and I could search for fav icon. So fav icon is this thing. That little thing right there. That's your fav icon. Okay? And so here, when I look for fav icon, oh, okay, HTTP handle, fav icon, ICO, not found. There's something not found handler. So it takes a handle, not handle func, and then you could drop in that not found handler. So I could just go grab that code. And I could drop that in here. And now I could rerun my program. And I could look at this. and bring it over. Just one. Because the second time was asking for a fav icon. But this time I've got this code that says, hey, fav icon, when you want that, guess what? Not found. So this will catch everything. If it's not matched somewhere else, it all goes to index. So that trailing / means everything. Okay, and it's in the documentation somewhere. I haven't looked at it in a while. Let's see if I can quickly find it. But just Command F and then look for / and only 640 to look through. All right, but maybe it's under handle func or handle. I'll pause this video since I can do that. Anyhow, I can't find it, but I could show you how that works. So I'm just going to get rid of this error stuff, just to keep it cleaner. And by cleaner, I mean more readable. It'd actually be cleaner to have all that error checking in there. And so now I'll just put in a couple more routes. Foo and bar. And watch what I'm going to do with bar, /. Okay, did you see that? Foo, bar, Control C to end your program and then run it again. So now I'm at index, and I could go to foo. It's not going to show anything over there anymore. Foo. It says hello foo, but I can't go foo dog. That takes me back to index. If I go bar, right? Bar runs bar, but I could do bar dog. And we're still at hello from bar. So why does foo take us back to index? Because if you do not have a trailing /, only that will match. That's it. Only when you have foo. If you have a trailing /, it catches everything downstream from bar. Because that trailing / is there. So I put bar dog, and that runs this code, catches that. Because that trailing / dog, it looks there. If I do foo dog, right, only this matches. There's no trailing /. And so the closest match then is this, which catches everything, including favicon.ico, if there's nothing handling that, which is why that ran twice. Once for when I asked for index, and once when the browser asked for favicon.ico. Does that make sense? So the takeaway from this video, trailing /. That's like a new piece of knowledge. That's good knowledge. Trailing / just means everything downstream, baby. And all that other stuff that could be beyond bar too. No trailing /, only this, that's it, only that. So takeaway is trailing /. And the other takeaway is this deal right here. The fav icon, you learned about a fav icon and what it is. And we can handle the fav icon with not found handler. So handle func, why handle func here and handle here? Right? People get a little overwhelmed with all the handle, handler, handle func. You know, people get a little bit overwhelmed with that. Why handle func up here and handle down here? Because handle func wants a value of type func response writer pointer to request, which is what index, foo, and bar are. Index is the identifier for this function, which is of type func response writer pointer to request. And so that's what handle func takes. It takes a value of that type, the function with that signature. Capiche? Handle wants a handler. So a handler implements the serve HTTP, implements the handler interface. It's a value that implements, it's a type that implements the handler interface. The handler interface is an interface defines behavior. Remember? If I exhibit this behavior, what interface am I fulfilling? Drunk. I am type person, and now because I have the behavior of this, I'm also type drunk. I'm of two types. If I have certain methods, certain behaviors, right, I implement other interfaces. And then I also become a value of that type. And so if something implements the serve HTTP method, it becomes type handler. Oh, I just flew past it. It becomes type handler, right? If anything has this method attached to it, if there's a type with that method attached to it, it implements type handler. And so wherever a handler is asked for, you can give that value. And so here we have a HTTP handle, and it wants a handler. So that allows us to create code which is more interswappable, interchangeable. Sometimes they'll call that polymorphism. And so you saw us use the not found handler. The not found handler. Well, let's look at that one. HTTP not found handler. Not found handler. There we go. I want to see where it is in the index, though. So it's under handler, type handler. There's the not found handler. So the not found handler returns a simple request handler that replies to each request with a 404 page not found. Replies to each request with 404 page not found reply. Okay, so it returns a handler. Not found handler returns a handler. And what does handle want? A value of what type? Handle wants a value of what type? Handle wants a value of type handler. Well, if I use HTTP not found handler, that returns handler. So this returns a handler, which is exactly what handle wants. And it returns a handler that responds 404 page not found. So it's just like a shortcut to not having to create my own little thing with the response 404 page not found. So that line of code right there is just like a new chunk of code. /favicon, handle, and HTTP not found handler.